Have you ever stood at an airport, looked at a massive plane weighing hundreds of tons, and just wondered, how on earth does that thing get off the ground? It seems to defy gravity, right? Well, today, we're going to unravel this mystery together. I'll break down the science of flight into simple, easy-to-understand concepts. No complex jargon, no boring lectures, just the pure, amazing physics that lets us soar through the skies. By the end of this video, you'll see flying not as magic, but as brilliant science. So, what's the big secret? It all starts with the wings. If you've ever looked closely at an airplane wing, you might have noticed its special shape. It's not just a flat board. The top surface is curved, kind of like a gentle hill, while the bottom surface is much flatter. This specific design, called an airfoil, is the key to everything. Why is this shape so important? Because of how it interacts with the air. As the airplane speeds down the runway, air splits to go over and under the wing. Now, because the top surface is longer and more curved, the air molecules traveling over the top have to move faster to meet up with the air molecules from the bottom at the back of the wing. It's like two friends taking different paths to the same destination. The one with the longer path has to run faster. This difference in speed is where the magic of lift begins. And to understand it, we need to talk about a famous scientist named Daniel Bernoulli. Over 250 years ago, he discovered a fundamental principle of fluid dynamics, which includes air. The Bernoulli principle states that the faster a fluid moves, the lower its pressure becomes. So, let's apply this to our airplane wing. We've established that the air on top of the wing is moving faster than the air underneath it. According to Bernoulli's principle, this means the pressure above the wing is lower, while the slower moving air below creates a zone of higher pressure. This pressure difference creates a net force. Imagine the high pressure under the wing pushing up more strongly than the low pressure on top is pushing down. The result, an upward force we call lift. It's this continuous push from below that literally lifts the entire aircraft into the air. But the shape of the wing isn't the only thing at play. There's another crucial factor called the angle of attack. You've probably seen planes take off with their nose tilted slightly upward. That tilt isn't just for show. The angle at which the wing meets the oncoming air is the angle of attack. By tilting the wing up slightly, pilots can increase the amount of lift generated. Why? Because a small upward tilt forces the wing to deflect more air downward. It's like when you stick your hand out of a moving car window. If you keep your hand flat, the air flows smoothly around it. But if you tilt your hand up slightly, you can feel the air pushing it upward, right? That's the angle of attack in action. This action of pushing air down results in an even greater upward force on the wing. However, there's a limit. If the angle becomes too steep, the airflow over the top of the wing can become turbulent and break away, causing a sudden loss of lift known as a stall. So pilots have to manage this angle very carefully. And this brings us to another giant of science, Sir Isaac Newton. His third law of motion is famous for a reason. For every action, there is an equal and opposite reaction. How does this apply to flight? Well, the airplane wing is actively pushing air down. That's the action. The opposite reaction is the air pushing the wing, and therefore the entire airplane, upward. Think about it this way. The wing is constantly scooping huge amounts of air and accelerating it downwards. Billions and billions of tiny air molecules are being pushed down every single second. In response, all those air molecules push back up on the wing. It's a continuous exchange of force. So, you can think of flight as the wing climbing on a giant, invisible staircase made of air that it's constantly pushing down beneath it. Both Bernoulli's principle and Newton's laws are at work simultaneously, complementing each other to explain the phenomenon of lift. Some physicists argue more for one than the other, but the truth is, they are two sides of the same coin, describing the same aerodynamic event from different perspectives. One focuses on pressure differences, the other on momentum transfer. Together, they give us a complete picture. So, to recap, flying isn't magic. It's a beautiful symphony of physics. It's the carefully engineered shape of the wing, creating different air speeds and pressures. It's the pilot's precise control over the angle of attack to maximize lift. And it's the fundamental law of action and reaction, with the wing pushing air down to be pushed up. All these elements have to work in perfect harmony. The thrust from the engines provides the forward motion needed to get air flowing over the wings, and once that flow is fast enough, the combination of wing shape, angle of attack, and physical laws creates the lift that overcomes the plane's weight. It's a delicate balance, a dance between four fundamental forces: lift, weight, thrust, and drag. And it's this balance that allows us to travel the globe, connecting people and places in a way that would have seemed impossible just over a century ago. It's truly a testament to human ingenuity and our understanding of the natural world. From the first flight at Kitty Hawk to the jumbo jets of today, the core principles remain the same. I hope this explanation has given you a new appreciation for the science of flight. It's a topic with endless depth, and we've only scratched the surface today. We could talk about how pilots control the plane using ailerons, elevators, and rudders, or dive into the complexities of supersonic flight. What about how helicopters fly? That's a whole other fascinating subject. If you found this interesting and want a part 2 where we explore some of these deeper aspects of flight physics, let me know in the comments below. Your feedback helps me decide what to create next. And if you enjoyed this journey into the science of aviation, please give this video a thumbs up and subscribe to the channel for more content that makes complex topics simple and exciting. Thanks for watching, and I'll see you in the next one.